Given a head of a linked list which contains a series of integers separated by zeros, the beginning and end of the linked list will have a node value of 0. And for every two consecutive zeros, merge over nodes lying between them into a single node whose value is the sum of all the merged nodes. The modified list should not contain any zeros. Return the head of the modified linked list. In an interview setting, you will want to start off by asking clarifying questions. For this problem, one of my clarifying questions is, what if there are consecutive zeros? For example, the first zero and the the first element and the second element are both zeros. Do we skip that, or do we allocate a node called 0 in our resulting linked list? Also, can we allocate extra space for our new linked list, or do we have to do this in place? So to answer my questions, I'm assuming that I would skip it if there are consecutive zeros, and I would just simply add the nodes that have actual values between each node, between each zero. And I assume that also going to allocate extra space for this problem. So I want to make a new linked list. To start off, what I'm thinking about doing is creating a sentinel node called, and I'll set that equal to list node -1 or something. And this node is going to be my new linked list. Also, I want to make a copy of that sentinel. So, for example, it looks like this: sentinel equals results equals list node -1. I also want to keep count of the sums of the nodes. So I will have my total sum equal to 0. And I'm also going to create a copy of my head. So I'm going to loop through my current linked list, and I'm going to essentially check whether the value is 0 or not. If current val equals 0, and if total not equal 0, then I want to create my sentinel.next equal list node total. I'll never set my sentinel equals sentinel.next. Well, you know that if else, I'll just append my current value to total. And I'm going to iterate through my next. Else total sum. Sorry, I keep on forgetting that it's not total, but it's total sum. That's the name of the variable. It works for this test case. Yeah, so it's faster than 15%. So to analyze the big O of this problem, of my solution, is I know I'm looping through my head linked list, or my copy of head linked list in current once. And that's essentially all that I'm doing, is I'm looping through my linked list. I'm traversing through my linked list once. So it'll be, my runtime complexity of this would be O of n, where n is the total number of nodes in my head linked list. And the space complexity of this will also be O of n, because where n is the number of nodes that don't equal 0. Thanks, guys.